Hello, everybody. I'm Hagatai from the Spirae, and it's been a pleasure to be part of this project with Kai and Anna and Oliver and the other members of the DTU team. So my presentation this morning is about feasibility study 1, which is the demonstration in the university laboratory setting of commercial software. And there's really a business process that underlies this, and it's actually, for small companies such as ourselves, it's not feasible to have, a large and flexible laboratory for demonstration purposes. And it's also not, especially in the early stages of software development or in sort of beta versions, we may not have a large number of commercial deployments that we can point to. So it's very advantageous for a company in our position to be able to work collaboratively with a university as a site for software demonstrations. So we wanted to prove this point out and sort of show the ability of software to come into a university laboratory setting, a research lab setting, for a quick demo. And that's what we did that's what we showed in feasibility study 1 here. So what you're seeing in the diagram here on the right is how we sort of abstractly, an abstract representation of how we configured Power Lab in Lyngby. And it's this very flexible facility, but sort of the key feature was that we wanted to use the existing power system assets that are there, which really consist of a number of micro CHP units, the rooftop solar with inverters, some loads, and of course the distribution infrastructure that sort of ties them all together. And so the particular configuration that we developed was really sort of call it a microgrid, if you will, consisting of a micro CHP and the rooftop solar and a load, and a single point of coupling to the utility. Another requirement was to use the existing CIT infrastructure of the lab. So as network servers, et cetera, none of that was changed or brought in externally. We also wanted to take advantage of the lab's underlying telemetry system, the ABB SCADA system that's deployed there. So the only thing we wanted to bring in was maybe several proprietary CAT components, so some hardware boxes, and the software itself. And the lab is not dedicated to any one user, so one key requirement was that we be able to come in quickly and rapidly switch over to this scenario and then get out without leaving a trace, if you will. So Kai, if you could go to the next slide, please.
Yes.
In an earlier slide, Kai showed this as sort of a five-month timeline, but really the first 3 months we just sort of talked about what would be possible and kind of got to the point of being able to describe the setup that you saw on the previous page and talked about what the requirements were and what the systems we wanted to integrate with. And really once we started detailed work, it was about an 8 or 9 week timeline. So there's a lot of planning that went in initially to really define what the interfaces would be to the assets, what would be done, what controls would be done, what personnel was required, etc. One of the key people to work with was the IT staff at the Power Lab, and they were able to give us remote access to one of the server nodes there. So about 3 weeks out, we were able to deploy software to that server node remotely. And the next thing we hoped to do at that point was to be able to already do the connection and the configuration to the SCADA system, the ABB SCADA system in the lab. And that's sort of where we hit a wall. We were unable to do that remotely, ran into a lot of problems. And so we did as much as we could remotely, but that one piece, and it was kind of a key piece because we were using that for power measurements throughout the lab, we were unable to accomplish remotely. About 2 weeks out, the detailed interfaces that we would have to the lab assets were published, and these were developed by Oliver. And what we used to create those interfaces, what Oliver used were these syslab nodes, which you've also already heard Anna talking about a little bit. And so brought some controllers into the lab to provide those uniform interfaces to the various assets that our Bluefin software would be integrating with. The diagram you see at the right is showing the interrelation among the various software components that were used during this feasibility study. So the blue box is Energy Research Manager, Control Area Manager. These are Spirae software components of our Bluefin system. There's a UI, client UI, which we use to visualize data and to enter commands, of course. And then for simplicity, we deployed a data concentrator, and we brought all the Modbus communications from the syslab nodes into this data concentrator, and then interfaced our asset interfaces directly to those assets by routed through the data concentrator. And then finally, we were supposed to get as I mentioned, interface information about power flows and so forth in the lab from the SCADA system. And again, that was a series of data we were bringing through the data concentrator. So we got on site on a Monday. Had 4 days to sort of prepare on site, and the final demo was on Friday of that week. And it really took until the day before the final demo until we finally cracked the nut of how to communicate with that SCADA system. And we'll come back to that point in the lessons learned, maybe. So next slide. So what we actually did was a very, from a point of view from a power system point of view and a controls point of view, what we demonstrated was simple. We just demonstrated one of the controls that's part of our microgrid package, and it's a simple import-export control. So we're using controllable assets, which in this case was the micro CHP in the lab there, to compensate for uncontrollable variation. And we had 2 sources of uncontrollable variation. One was the solar generation from the rooftop solar, and of course, since it was November in Denmark at about 3 in the afternoon, that wasn't the largest source of variation at that point. And so we also used a load bank that was running a load profile to provide some additional interest to the power flow in the lab at that point. And if you sort of see the left portion of the trace there, you see some variability, and then we brought the CHP on, and then the orange line represents the set point that Bluefin was controlling the entire system to by varying the CHP's output, and then about a third of the way, a quarter of the way across, you see that we changed the set point, and you see the CHP compensating for that set point change, and then controlling the power flow at the point of coupling to the utility to that set point for the next 10 minutes or so. That's about the length of the time we ran for. So again, a very simple control, and certainly not anything new from that point of view for what was actually demonstrated. If you go to the next slide, this is really sort of what came out of this. I mean, the real value for us and is not the actual control, and you've heard Anna talk about simulations, and we do the same thing. It's quite convincing to demonstrate control against a software simulation, and we have a way of interfacing our control software against a simulation, so we're not simulating the control, we're simulating the power system, and the sort of the complexity of the control can be quite well demonstrated in that setting. On the other hand, what's much harder to demonstrate against simulation was actually involved in deploying to the field, to an actual field environment, and configuring communications and showing the flexibility of a control system to deploy in various environments like that. And so we see that as the real value of doing a demonstration like that, is the ability to come into a new environment and to rapidly deploy against new assets and show the communication, show the coordinated control, and showcase that portion of our system. So key learnings from this process for us, and maybe for Power Lab going forward as well, is and this is coming back to that integration with the SCADA system. Just because both systems support protocol, whatever the protocol may be, it was OPC DA in this case, and Bluefin supports that, and we had documentation from ABB that showed that their SCADA system supported that, and so we made the decision that was the interface we would use when we came to Power Lab. Of course, there's no guarantee that you can actually successfully communicate via these protocols, and so in the end, when we finally figured out what was going on, it turned out to be an issue of incompatibility between 32-bit and 64-bit systems. But those are the kind of details that are rarely documented, and in the end, there was some heroics from the gentleman at ABB who was able to provide a different version of the OPC interface on their end, and once we had that, it became fairly straightforward to integrate. Details of the APIs. This was really when I was mentioned that Oliver provided those details a couple of weeks before, that was plenty of time, but it was really valuable to have those published ahead of time, so we were able to prepare for that. So having clear interfaces published definitely enhances the ability to rapidly come in and turn around a demonstration like this. Prior to this, I think lab assets at Power Lab had been largely used as sort of single asset, as part of single asset experiments. And I think one of the, from the Power Lab point of view, one of the nice features of this demonstration was that we were able to demonstrate this sort of coordinated control of these different assets using that previously had not been brought together under a single supervisory control. Supervisory is probably not the right word. Coordinated control, and so this was kind of a new step for Power Lab as well. And I think this last point I already mentioned before, that the real value was for us was the ability to demonstrate rapid deploy in a new environment. Much more so than the actual control or the UIs that we showed. So hopefully you were able to hear all that. Again, I want to thank DTU for the opportunity to participate with them in this project, and we look forward to further collaboration between Spirae and DTU.